Here's the next topic for me to cover, graphing quadratics. All right, so the idea here is that you're going to identify various parts of quadratic graphs, and then you're going to solve quadratic functions using graphs. So I guess the first thing, let's look at this. Okay, start with this, f of x is equal to x squared. That is the quadratic parent function. Everything we do is based off it's based off of this type of thing. And then what the quadratic function is special in that it makes a parabola. Parabola is like if you look at this, notice here how the y's, or f of x, the dependent variable, is repeating. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and graph, and here you go. The function that is formed there is called a parabola, or the graph that's made there. Every parabola has a max or min point, which is what is located at what is called the vertex. At that vertex, again, the vertex gives you a max or min value point, and it gives you an axis of symmetry. The axis of symmetry is a point where a line, let's say a vertical line, that would cut the graph in half and give you two equal halves. Like if you were to fold it there, they would fold on top of each other. This all occurs at the vertex. Okay, the vertex will give you something here and give you that max or min, let's say value instead of point. Now, I'll tell you more about these as we're going through them, but you might see some things, but almost all that information you're going to need is going to come from the vertex. Keep that in mind. Okay, so let's look here and talk about vertex form. Vertex form, you might want to copy this down. I'm just going to give it all to you. We're going to say, don't worry about the B. Don't worry about the B. I'm going to actually erase that. Let's get rid of that. Let's just focus on A, C, and D. Okay? Plus or minus, when it's a positive in the very front, it's going to tell you it's going to go up. Negative, it's going to tell you it's going to go down. Up means you're going to have a min. Down means you're going to have a max. So you kind of keep that in mind. C tells me to go left or right. A positive, I go to the left, and a minus, I go to the right. And then D, I go plus, minus. Notice C is inside the parentheses, D is outside and at the very end. A is always in the front. Okay? If A is bigger than 1, it's what we have a vertical stretch, and if it's between 0 and 1, we have vertical compression. And you'll see some examples of all these things as we go through it. Okay, so next part here. Let's compare these two graphs. Here's the parent function y equals x squared, and here's the parent function x squared plus 4. Okay. When you're graphing, you start at, like, let's say 0, 0. And there is something what we call a quadratic slope. And the way I use quadratic slope is these are your three basic numbers, 1, 3, and 5. And what that means is I went up from the center, from the vertex. I went up 1, and to the left and to the right 1. Then from there I went up 3 to the left and to the right 1. Then I could go up 5, 1, 2, 3, 4, 5, and over 1. And that would give me my graph. Okay? That's using these numbers. These numbers tell me how much I go up, and then I always go to the left and to the right 1. All right, so for 4, this means I'm going from here, according to this, I'm going to go up 4. So I'm going to go up 4, and you can see this completed product here. I go up 4, and then I went from here, I went up 1 over 1, up 3 over 1, and then if I had room, I would go up 5 and over 1. The vertex was 0, 4. That's this point right here. It's a minimum value because it's pointing up, and that min value is equal to 4. And the axis of symmetry will always be x equals 0. Notice that these two numbers appear in the vertex. Okay, so now let's compare this to another one. Okay, so let's graph x minus 4. Now notice, this green one is my normal y equals x squared. This one's x squared. Don't worry from there. Minus 4, according to your vertex form chart, tells you you're going to go to the right 4. So I'm going to go with this point right here, the vertex. I'm going to go 1, 2, 3, 4. Okay. Then from there, I'm going to use my quadratic slope. I'm going to go up 1, over to the left and to the right 1. up 3, 1, 2, 3, and to the left and to the right 1. Once you've got at least those points, you're good. Okay, if you have room, you can always do the 5. Okay, now I can see here that my vertex is at 4, 0. My max or min value, it's a min value because it's still facing up, and that's equal to 0. And then my axis of symmetry is x equals 4. Okay, I will talk more about solving this in a little bit, but I want y'all to see these characteristics. Okay, of course it's facing up, and we can see other things. All right, let's do one more example like this. Okay, so I have here x plus 2 squared, and then minus 3. So this tells me the plus 2 is in the parentheses, and that tells me I'm going to go to the left 2. And the minus 3 tells me I'm going to go down 3. So I went down from 0, 0. I went to the left and down. That gives me my new vertex. And from there, I am going to go up 1, to the left and to the right 1. So that number right there, notice, is my vertex. And I'm going to use my quadratic slope to help me get this next points. So from the vertex, I'm going to go up 1, over to the left and to the right 1. Then up 3, over to the left and to the right 1. I could go up 5 and over to the left and to the right 1. Connect all those points, and there's my parabola. The vertex is negative 2, 3, and you might see a resemblance of that to the numbers that are right there in the function. It has a min value at negative 3 and an axis of symmetry at x equals negative 2. Okay, so that means right here there is a line, dun, 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 that will cut this into equal halves. Okay, that's what this means. So you can kind of see how this works and kind of go from there. Now, these two, if I were to look for these 2 points right here where they cross the x-axis, these points right here are known as roots. Those are the solutions to the quadratic function. Okay, so we're going to call those roots. How do you find those roots? Well, let's talk about that. So you have a graph page open. There's 2 different ways that you can find the roots. Probably the easiest way is to do a graph trace. So that means you're going to press menu. Okay, so press menu. Choose option 5. And then choose option 1. And that will allow you to move the cursor left or right. So you'll be able to move the cursor left or right to find those intersects. It will actually tell you that you've reached what's called a 0. So it will say, the calculator will use the word 0, but 0, roots, x-intercepts, they all mean the same thing. They're all basically solutions of the equation, of the function. Okay? So that will be what you could do to do it on a calculator. And I'll show you more of that in class. So let me do one more example, and we'll kind of go from there. Okay, so I'm going to go through this little equation. This one has a little bit of everything. I'm going to try to go through it a little slowly, but cover everything. All right. I can already tell this number right here tells me I got to go to the right 1 and then up 5. 1, 2, 3, 4, 5. There is my vertex. So my vertex is at positive 1, positive 5. Okay? Then if I want to get my next points, I need to actually take this number in the very front. Normally I use 1, 3, and 5, but I'm going to multiply them by the a. So if there is a number there other than 1, you need to multiply. That number will multiply the 1, 3, and 5, and I get negative 2, negative 6, negative 10. I probably won't have room for the negative 10. So that means that's a negative. That means I go down. So from here, from the vertex, I'm going to go down 2, to the left, and to the right 1. Down 6 more, 1, 2, 3, 4, 5, 6, to the left, and to the right 1. Okay, so I get some type of graph like this. Now, this one is facing down, so that means I have a max value. Not a min, but a max. That's a maximum point right there. And that max is at 5. The axis of symmetry is equal to 1. And then, what are these points right here? Well, that's where I would go and tell you the roots, and I would use my calculator. The roots are, and let's find out. Okay, according to the calculator, when I did the menu 5, 1, and I pressed sideways, I went to this point and it said there was a 0 at 2.58. So one of my roots is 2.58, or one of my answers. The other one happened at negative 0.58, so negative 0.58, and there you go. That's that. So these two answers, those are my two roots. Those would be my solutions to this function. So that's all that I can use to find out all the different aspects of the thing, and that's pretty much it. So if you have any questions, feel free to ask in class. Thank you very much.